There is a planet we all live on. It is called Earth. 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 And Earth is its name.
Good afternoon, everyone. Our PowerPoint presentation is based on the structure of the Earth, and our group members are as follows: Ms. Trishana Jarrett, Ms. Colleen Abraham, Sir Han Thomas, Ms. Velda Merriman, Ms. Shania Lau, Ms. Sally Daniels.
The Earth is composed of several layers, each with its distinct characteristics, importance, and functions. Understanding these layers is crucial for predicting natural disasters and locating resources. These layers can be broadly classified into two categories: compositional layers based on chemical composition. This include crust, mantle, core. Mechanical layers based on physical properties. This include the lithosphere, the attentosphere, the mesosphere, inner core, and outer core. Layers of the Earth. We have the crust, mantle, outer core, inner core, lithosphere, attentosphere, mesosphere. The crust. This is the outermost layer of the Earth, varying in thickness from about 5 to 70 kilometers. It is composed of lighter rocks and minerals, primarily granite and basalt. The crust is divided into oceanic and continental crust, with the oceanic crust being denser and thinner than the continental crust. The crust is where most of Earth's resources are found, including minerals and fossil fuel. Mantle. The mantles lie beneath the crust and extend to the depth of 2,900 kilometers. It is comprised of silicates, rock rich in iron and magnesium. The mantle is divided into upper and lower mantle. The upper mantle is solid while the lower mantle is partially molten. The mantle is crucial for plate tectonics as it is the source of magma that forms new crust at mid-ocean ridge and contributes to volcanic activities. Outer core. The outer core is liquid layer composed mainly from iron and nickels, extending from 2,900 to 5,150 kilometers below the surface. The outer core is responsible for generating the Earth's magnetic field through the dynamo effect, which is essential for protecting the Earth from the solar radiation. Inner core. The inner core is a solid sphere of iron and nickel with a radius of about 1,220 kilometers. It is under intense pressure and heat, which keeps it solid despite the high temperature. The inner core plays the role of the Earth's magnetic field and helps maintain the planet's thermal balance. Lithosphere. This is the outermost rigid layer composed of the crust and the uppermost part of the mantle. It is broken into tectonic plates and moved and interact, causing volcanic activities, and mountain buildings. Asthenosphere. This layer lies beneath the lithosphere and is highly vigorous, mechanically weak, and delicate region of the upper mantle. It allows the lithosphere to move over it. Mesosphere. This is strong, rigid part of the mantle below the atmosphere. Pressure increase with depth, making the layers more rigid than the atmosphere. Characteristics of the Earth's layer. Crust. Characteristics of the crust. The outermost and thinner layer, it is composed of solid rocks and divided into two types. Oceanic crust, thinner, 5 to 10 km, denser and composed mainly of basalt. Continental crust, thicker, 30 to 70 km, less dense and composed mainly of granite. The importance of the crust. The crust is where we live and where all geographical processes occur. It contains the resources we use and supports all life. Mantle. Characteristics of the mantle. The thickest layer, making up about 84% of the Earth's volume. It is composed of silicate rocks rich in iron and magnesium. The mantle is mostly solid, but behaves like a very viscous fluid over long periods. The importance of the mantle. The mantle convections currents drive plate tectonics, which shapes the Earth's surface, causing earthquakes and volcanoes. Plays a role in the Earth's heat budget. The core. Characteristic of the core. The innermost layer, composed mainly of iron and nickel, it is divided into two parts. Outer core, liquid due to high temperature, and the inner core, solid due to immense pressure. The importance of the core. The movement of liquid and iron in the outer core generates Earth's magnetic field, which protects the Earth from harmful solar radiation. The inner core helps stabilize the Earth's rotation. Lithosphere. Characteristics of the lithosphere. The rigid outer layer composed of the crust and the uppermost part of the mantle. It is broken into plate tectonics, or tectonic plates. Importance of the lithosphere. The lithosphere move and interact, causing earthquakes, volcanic activities, and mountain building. Attentosphere. Characteristic of the attentosphere. A highly viscous, mechanically weak, and the ductile region of the upper mantle. It lies below the lithosphere and allows the lithosphere to move. Importance of the attentosphere. The attentosphere allows the movement of plate tectonics, which is crucial for plate tectonics and the recycling of the Earth's crust. Mesosphere, that is the lower mantle. Characteristic, the stronger and rigid part of the mantle below the attentosphere. Importance, it plays a role in the mantle convection, although its exact contribution is still debated. Thank you.
How we study Earth's interior. Since we can directly observe Earth's interior, scientists use a variety of indirect methods. Systemic wave. This is the most important tool. Earthquake generates seismic waves that travel through the Earth. Types of waves. There are two main types, P wave, primary, and S wave, secondary. P waves are compressional and can travel through solids, liquids, and gases. S wave are shear wave and can only travel through solids. How they help? By analyzing the speed and path of these waves, scientists can determine the density and composition of different layers. S-wave shadows, area where S-waves don't reach, indicate the presence of liquid layers, like the outer core. Refraction and reflection of waves at boundaries between layers also provide information. Heat flow. Measuring the heat escaping from the Earth's interior provides clues about the processes occurring within. Magnetic field. Studying the Earth's magnetic field helps us understand the dynamics of the outer core, which is thought to be responsible for generating the field. Gravity. Variations in Earth's gravity field can indicate differences in density within the Earth. Laboratory labor experience. Scientists conduct experiments at high pressures and temperatures to stimulate conditions in Earth's interior and study the behavior of rock and minerals.
How understanding Earth structure helps in predicting natural disaster and finding resources. We have predicting natural disasters. Here we have understanding plate tectonics helps predict earthquakes and volcanic eruptions, monitoring seismic activity and magma movement aids in early warning. Earthquakes, understanding the structure of the earth, especially in the location of fault and plates boundaries, is crucial for assessing earthquake risk. Seismic monitoring networks can detect small tremors that may precede larger earthquakes. We have the volcanic eruption. Knowing the structure of the earth crust and mantle helps scientists understand how magma is generated and how it rises to the surface. Monitoring volcanic activity and analyzing the composition of volcanic gas can help predict eruption. Tsunami. Earthquakes that can occur on the ocean floor can generate tsunamis. Understanding the locations and magnitude of these earthquakes is essential for issuing tsunami warnings. And we have finding resources, oil and gas. Understanding the structure of sedimentary basins is crucial for finding oil and gas deposits. Uh, Geologists use seismic surveys to map the subsurface and identify potential reservoirs. We have finding resources, knowledge of crustal composition guides mineral and fossil fuel exploration. Understanding mantle dynamics helps locate geothermal energy sources. We have mineral deposits. Many mineral deposits are formed by geological processes that are related to the Earth's internal structure. For example, hydrothermal deposits are often associated with volcanic activity. Understanding these processes helps geologists find new mineral resources. And geothermal energy, where geothermal energy is heat from the Earth's interior, understanding the distribution of heat within the Earth is important because it's a developing it's developing the geothermal energy resources within the earth. It's also very important since it's the understanding of distribution of heat within the earth. And we have the conclusion. In conclusion, we have earth structure dictates its dynamic processes. Convection in the mantle drives plate tectonics, shaping the surface. The liquid outer core generates a magnetic field protecting the planet. Understanding Earth's layers is crucial for comprehending geological phenomena. Future research will continue to refine our understanding of this complex structure.
Okay, there we had our little presentation based on the structure of the earth. Now we have the question and answering segment, question and discussion. So the first question from the presentation, what you've got. So our first question here is, what are the four layers of the earth? What are four layers of the earth?
We have the crust, the mantle, the outer core, and the inner core.
Very good. Question number 2. Which layer of the Earth is responsible for generating the planet's magnetic field?
The outer core is responsible for the Earth's magnetic field.
Question number 3, the final question. Why is it important to study the Earth?
It's important because it helps us to understand our planet and how to live on it sustainably.
Thank you.